Question 6 is this wonderful situation where there's two different triangles that you can get from the information given. If we just put the first line here, that we've got Q and R, and we know that that's 8 centimeters long. We also know that R is 30 degrees. But the other piece of information, that P is somewhere on this line here, so that Q to P is 5 centimeters. And it would look like that. The issue is that if you did this with a compass and you measured 5 centimeters here, you might notice that also that you could have 5 centimeters here as well. And so there's an alternative position for P there. Let's work out this angle here then. Let's try and work out this one. And it's going to be a sine rule, that the sine of P over opposite side is 8 equals the sine of 30 over the opposite side of 5. And so the sine of P equals, just tap that in the calculator, sine of 30 is a half, divided by 5, times by 8. That makes it 4/5. So the angle that we've got there is the inverse sine of 4/5, which is 53.1 degrees. So that's the angle there, 53.1 degrees. But this angle here is an obtuse angle, and the obtuse equivalent of this one here is 180 take away. On a sine we do 180, take away the first answer, and so the alternative one here is 126.9 degrees. That's this one here, 126.9. You don't believe us? We'll just push sine. Sine of that answer gives 4/5, the 4/5 that we had there. So there's our two angles for P, and what are we asked to now? We're now being asked to find out what that distance there is. I think probably the easiest way of doing that is another sine rule, isn't it? That you've then got, if we do that, if we find out what that angle there is, so 180, take away the 30, take away the 126.9, that's telling me that that is 23.1 there. And so I'm going to do this one here that we want, P dash times R divided by the sine of 23.1 equals opposite side, that one there, 8 over the sine of the 126.9. Losing my accuracy here, I've not kept enough values in the calculator, so I'm going to have to do this with rounded answers, times by the sine of 23.1. So that distance there, that one there is 3.92. 3.92, I hope that's accurate enough. Might be 3.93 actually if you do that a bit more accurately. The other one here I'm going to do in a similar way. I'll work out what that big angle there is and then do a similar sine one there. I think that longer one there is going to be 9.93 when you work out that big long one there.